Example 5. Find all asymptotes of f of x equals 2x squared plus 2x minus 4 over x minus 2 times x squared minus 1. In order to find the asymptotes of a rational function, rational fractional function, we're going to first want to try to factor this if possible and get it into lowest terms. So my numerator, I can factor out a 2, and I'll be left with x squared plus x minus 2. In the denominator, I can factor my x squared minus 1 into x minus 1 times x plus 1. I've got a difference of squares. Now in the numerator, my trinomial x squared plus x minus 2, I can break that down further into x plus 2 times x minus 1. Now I can see I have a common factor of x minus 1 in the numerator and denominator. So I want to divide out that common factor to get it into lowest terms. So that leaves me with 2 times x plus 2 over x minus 2 times x plus 1. Now my function's in lowest terms, and I can identify the asymptotes. So first, my vertical asymptotes that I'll abbreviate VA. So to get vertical asymptotes of a function, you're going to look at the denominator of the function in lowest terms and identify any values that make that denominator 0. So if I set my denominator, x minus 2 times x plus 1 equal to 0, I can see I'll get an x value of 2 and an x value of negative 1. So I have two vertical asymptotes, x equal to 2 and x equal to negative 1. Note that we had a common factor of x minus 1. If we had not reduced this function, we may have mistakenly thought that we had a vertical asymptote at 1, but that common factor actually indicates there's a hole in the graph there, which it doesn't ask us to find that in this question, but that's an important note. When you go to sketch these in the next section, that will be an important feature. But for now, we're just looking at the function in lowest terms, and we see that our two values that make the denominator 0 are 2 and negative 1. So we have vertical asymptotes at 2 and negative 1. Now, for a horizontal asymptote, or oblique asymptote, remember a function will have one or the other, but not both. So to define if we're going to have vertical if we're going to have horizontal or oblique, we're going to compare the degree of the numerator and the degree of the denominator. You can make this comparison of the function in the original form or the reduced form. Either way, the comparison will be the same. So if we look at the original function, the degree of the numerator is 2, it's an x squared. In the denominator, the degree would be 3 because we've got x to the first here, x squared here, so if we multiply that all out, we get x cubed. So we can see the degree of the denominator. So the degree of the denominator is greater than the degree of the numerator. And that tells us then that we have a horizontal asymptote, I'll abbreviate HA, at y equals 0. So we have two vertical asymptotes, x equals 2 and x equals negative 1, and we have a horizontal asymptote at y equals 0. This question doesn't ask us to graph it, but just to kind of reinforce and visualize what we're finding here. If we enter this function in the graphing calculator, first of all, be careful when you enter it. It's always a good idea when we're entering rational functions into the calculator to enclose the entire numerator in its own set of parentheses. So I've got the 2x squared plus 2x minus 4 in its own set of parentheses. And then in the denominator, you need a broad set of parentheses first, then put the two factors inside. So you've got to have double parentheses here. So it's parenthesis, parenthesis, x minus 2. And here when you close the parentheses, you close the x squared minus 1 and then put another parenthesis on there. That's important when you enter these in the graphing calculator. So now if I go to my graph, I can see here, so we determined that we had two vertical asymptotes, two vertical splits in the graph, and we can see that here. This certainly looks like this could be a split at x equals 2. This certainly looks like it could be a split at x equals -1. And it certainly looks like this graph flattens out and approaches the horizontal asymptote of y equals 0. And if we just explore here on the table, as we would expect, at -1 we have an error because that's the location of the vertical asymptote. At 2 we have an error, the location of the other vertical asymptote. And then notice here we've got a third error at 1, but if you remember we had a common factor of x minus 1 in the numerator and denominator, so that means there's actually a hole in the graph there, which they didn't ask us to find in this question, but just note that that error indicates there's a hole in the function.